Okay, Bismillahirrahmanirrahim. Assalamualaikum. So in this video I will explain on task 8. Okay, so task 8 is basically we're going to deploy everything that we've just deployed before. Um, our application, our desktop application, and we're going to deploy it using AWS server, so it will be hosted over the internet. But before we just use localhost as a server, local server, which is we use Flask, and then we use tunneling. We use ngrok to tunnel the localhost and host the client over the internet. So now we're going to deploy all of those clients over the internet using AWS. Okay, so firstly we need to go to our AWS. Okay, so here we click the EC2 here, and firstly what we need to do is we need to create a security group, new security group for our new instances or server. Okay, you just click here, and then you just create your security group. You write in your security group. For me, before I write in RESTful API here, security group, and then you need to set inbound rule to SSH and from all source, and same as HTTP from all source also. So inbound rule there are two. Okay, then once you've done, you just click here, create security group. Okay, so I've created mine, so this is my security group. Okay, once you're done with that, you also need to create key and pair. You go to key pair tab here, then same as before, you just click create key pair, and then you name your key and pair. You don't need to change anything here. So for me, I just type in RESTful API key, then you just click create. Okay, so this is my key pair for this RESTful API. Then once you've done with that, you go to instances mid server, then you launch instances. Here you launch instances, you name your server. Like me, I name it RESTful API server, something like that. And then once you've done naming your server, you click on Ubuntu here. We're using Ubuntu. We use free tier, and then you just choose your key pair you created before, RESTful API key, and then your security group, or other word, firewall for protection. Okay, so here you also choose the one that you create before, which is for me is, where is it, RESTful API security group here. Okay, once you've done with that, you launch instances. So for me, I already create my server here, RESTful API. Okay, so click that. Then once you've done with that, you go to PuTTY application that we've already downloaded before for MQTT. So you go to PuTTY, then you copy your server IP address, public IP address, IPv4 here. And then you just paste here. Once you've pasted, you go to SSH next, and then you go to authentication, and then you go to credential. So here in credential, you need to find your API key, your key that you created for your server. So this is mine, so I'm gonna click open here. Open. So once you've done with that, you just click open here. And once you've clicked open, like me, I already create open. Then you go to Microsoft Karase, Microsoft, not Microsoft.net IoT cloud, and then you go here, click here. It'll be in this Google document here. Then you go to RESTful API here. Once you click that, show this. Then what you need to do once you're in this putty, you need to create sudo password root. Mean you need to create password for super user. Then once you create that, then you just get into super user. You just type in, you just copy this, and then you enter, and then you type in your password. It is shown before in MQTT. So after that, after you're in super user mode, then you click here, you go back here to this Google document, and you click here, and you're directed to this. So for the first part, you just copy this part right here. I think this is to download MongoDB server, something like that. Then you just paste here, and then you click enter in your command space for putty. After that, you also need to copy this lines here, line of code, and then you also need to paste and run here in putty workspace. After that, this part right here, so I think this part right here, what is it, EOL. So this part right here, echo and everything until the bottom. I'll show you. So then you copy all the rest. This is for web application, and then you paste same in this putty workspace here. Once you download, you press enter. Once you paste, you press enter, and then you go back to your server, AWS. Then you copy this public IP address, and then you just paste. So you will get here, you will get this web application. So that is done. Okay, so then web application is done. Then we also need to prove the endpoint of this AWS. The endpoint for this URL given to us by AWS. Then we can test this URL in Thunder Client. Okay, for example, here I'm gonna get by ID. So yeah, you paste your public IP, AWS public IP. So I want to get data with ID 1, or maybe let me change. I think I'm gonna get data with ID with ID 2. Okay, so we go to change ID 2, and we send request, and there we go. This is our data that we request, data with ID 2. Okay, so get is done. then maybe post. Let's try to post LED1. So this, change this URL. This is URL from before. It is ngrok. Change to our AWS. So we change to server by AWS. So we use this. We take this public IP, and we just paste here. Don't take that. Take from this website, web apps. Okay, so then we just paste that URL here, and then we just paste, and then we just send the request. Yeah, sensor added successfully. I think not sensor lah. I think the LED data is added successfully. Okay, so we can look at the can look at all the data by just take the IP from the server that you create in AWS, just paste here, and then take slash API multiply host. This is also a request. We make a request from our web browser, so literally we make requests to get all data from our web browser to the server, which is the AWS. So here it is. This is the newly created data that we create from Thunder Client. Okay, so then we try get all. Let's see. So this is already we already use AWS URL here, server. Okay, so then we send request. We want to get all the data. Okay, so here it is, the data we request, and status successful 200, server response. Okay, then we try to update. Same as before, change this URL that we used previously using an ngrok, and we just paste. Let's take the IP address of our server, then we also paste it here. We want to change state in data ID 1. So here in data ID 1, state is 0, so we change from 0 to 1, so we change here. Okay, then we send request. Updated successfully. Okay, so we go back here, we reload. So now our data with ID 1, the state is 1. We change it already. So after that, lastly, we can try delete. So all of this is just to prove that even not even, it's just to prove that using AWS, we can also get to the same endpoint by using all the HTTP request method. Using the IP address we from the server we create from AWS, can also do the same thing as using like local host server from Flask, and also like before we use we even use tunneling. So like before, we paste, then we send. So we want to try to delete data of ID 4, since it is out of place. Okay, so then we just send this request. sorry, forgot to add to type in the ID to data. So yeah, sensor deleted successfully. Okay, I think should not have sensor. That's a bit weird. Okay, then we look at our all the data. We look, then there's no more data ID form. So that is done to prove that our endpoint when using this URL or IP from server we created from AWS, it functions similarly. All the HTTP request method is done correctly and functioning as we like. Okay, so then we want to try and create, once we've done that, we also want to try and create desktop application. Okay, so desktop application, how we can do this is that how we can make it work is by first I'm gonna close this first, all of this request from the client. So we go to our app.py here in kv folder. So this is the code for our desktop application. So what we need to change is that we need to change this API URL. So before we use localhost, the URL is given to us by the Flask. Then we use ngrok, and then we just we use AWS server. So we just change the URL given to us by AWS server, and we just paste, and then the request method here we remain the same. API view1 GPI was, it's not request, it's just that the URL needs to stay the same. Okay, so once you've done with that, let me close the application first. Then you can run this code, desktop application code. You run the code. Okay, so once done, so this is the output, this is the desktop application. As you can see, the information in this desktop application is equal or tally the data we request here in our web browser. So for example here, ID1, the state is LED1, the state is 1. So LED2, the state is 0, and LED3 1. So it's the same. So okay, so that is done for, I think, no, before that we can try and test this desktop application. Let's try. So let me change to for everything to be in state 1. So reload. So now every data in this database is in state 1. Change it using this desktop. So now I want to try also change all the data into state 0. Okay, we reload. So here all the data is in state 0. Okay, so desktop is done, web application is done. We also already proved the endpoint for our HTTP request method with TAN client. Okay, so now we will be using, or we will use another client, which is ESP32 plus LED. So this is a thing, it is a physical thing. So this will be our next client here. As you can see here, this is my circuit. Okay, so I'm gonna use this to get all the data and to read all the data in database and translate it into uh, switching of LED. So for example, if the LED state is 1, the LED in my circuit here will light up. If it's 0, it will switch off. So now we go to VS Code. You need to create a new folder called the thing AWS. Okay, so now once you create that, you also need to copy and paste boot.py so that our ESP32 can connect to the internet. And then we create new file, main.py. Okay, once done, you need to code this. This is the code to get all the data from database. So basically what this code tell us or how its function is that we import your request library to use get method. So here, this is the get method. So you're going to use that get method to get all the data in the database. You can request that to the server. Okay, so here, also in the URL here, you need to change to the one that is given to us in the AWS server. So you also change that too. So all of this is just like a repetition of the previous code we've done in MQTT. We want to retrieve the data basically. So basically once we retrieve the data will be in JSON, and we want to read we want for this VS Code to read our data, our retrieve data. So we use also JSON, which is we will import loads. This method, it will convert the JSON data into Python. So once done, this below is just to this code below is just to arrange how the data is shown to us in the terminal. And also we also import library machine library so that we can use the pin I think it's method pin method here, so that we can control the switching of the LED, tallying with the information given, the information we retrieve in the JSON format. Okay, so we're done with that. So let's try this code. Okay, so first connect your ESP32. Once you connected, you upload first to your device, and then you run, the file on the device, on the ESP32. It is running, but my LED is not switching on. I think there's some problem here. Check the pin. So this is the disadvantage of playing with things. It is so very fragile. Yeah, so Right, currently all of the LED is switched off. Okay, so this is basically my circuit here. So currently everything is switched off. So we can control this circuit using, first we can control it using the web application here. We do this web application. So everything is switched off. So as you can see in my circuit, no LED is switched on. Okay, let's try. Let's try one LED is switched on. Okay, so here, as you can see, one LED is switched on. And let's try switch on all of this LED. Okay, wait. Okay, so now as you can see, all of my LED here in my circuit is switched on. Okay, so we're done with this web application we already test. Then we can try test the ESP32 client with LED using this desktop application. So we can also try switch on one LED first. Okay. So I have switch on LED 1. Okay, so as you can see in my circuit, the LED 1 is light up. Okay, let me try to switch all LED. Okay. Wait. Oh my god, there is a pin coming off. This is so inefficient. My pin connection is not good. Okay, so right now, in my desktop application, I switch on all the LED. So as you can see in my ESP32 plus LED client here, circuit, all the LED is switched on. Okay, so then I'm gonna switch off. Okay, so now all the tasks, task 1 until task 7 is shown and proven using AWS server. I think we can also control this client, ESP32 client with Thunder client. So I want to try that. Let's go to put for update. So here in my circuit, all of the LED is switched off. Okay. Now I want to try LED 1. I want to switch on. So I will send request here using Thunder client. Okay, so it's successful. Okay, yes. As you can see here, our circuit light up only one LED, which is LED 1. Okay, so that is perfect. Okay, so I'm gonna change it back to state 0. Okay, you wait, and it will switch off. Yep, perfect. Okay, so that is done. So I think that is all for task 8. So yeah, I think that is all for task 8. Okay, assalamualaikum and thank you.